Okay, so when we fill in our log properties, we're filling in our log properties paper. You already know these though from the flip video last night. Okay, so we're just writing them down so we have them in our notebook. Okay, so log base b of x times y equals what? Log base b of x plus log base b of y. Very good. Okay, so what about the next one? Log base b of x divided by y. Log base b of x minus log base b of y. Okay. Okay so far? You're remembering all this, right? So tell me the correct vocabulary words that go into the next column. The log of the quotient is equal to the blank of the logs of the argument. I know you want to say subtract. I want you to say the right word. Somebody just said it. Difference. Very good. Okay. Log base b of x to the p power equals p log base b of x. Very good. The log of a number raised to a power is the same as the blank, the log of the argument. It's actually two words, just so you know. Otherwise it doesn't make sense. It's the power times the log of the argument. Okay? So there's two more down here that we didn't go over in the flipped video, but if you think about it, we kind of did. Okay? Log base b of b to the p. What does that equal? Yes, absolutely. Just p. What about log base b of b? Ooh, y'all are good. Okay? Okay, so next page. Here's where we apply some of this stuff. How about page 3? Page 1 is one of the things that you would have had to do had you not watched the flip video, plus the other 2 pages that I have. Aren't you glad you watched the video? And I apologize. I told you an untruth. I told you the video would be between 5 and 7 minutes. It was only 4 minutes and 50 seconds. I apologize. I let you down. I'm so sorry. Okay, I'm so sorry. Okay, so we're going to start right here at E. Okay, we're starting right here at E. I would like you to rewrite this as just one expression. I only wanted to say log one time. Okay, so it's really kind of going backwards of what we just did, isn't it? Okay, so how am I going to rewrite this? If I'm adding logs, what am I really doing to their arguments? Ooh, multiplying. So this is really log of 10, right? So do you see how this might help if I said log of something, log base something of x? Do you see that how then I could be able to get it together with other stuff and be able to solve? Maybe not yet, but you will soon. Okay? So what about this? Log of 500 minus the log of 5. What's that going to equal? Log of 100, and you know that because it's log of 500 divided by 5. Okay? Log base 5 of x minus log base 5 of 10. Log base 5 of x over 10. Yeah, absolutely. So what about h? Don't let h fool you. But that's what you said, Jacob. Kind of, right? What you said was log base 3 of x plus 1 squared, right? I just did the math. I just did the squared. Okay? What about I? I will make it clear what I want. How about that? I will make it clear whether I want this or whether this is okay. Sometimes it'll depend on the situation, Jordan. If we're trying to solve for x, you got to go ahead and go here. Unless there's something over here on this side. We'll talk about that, I promise. Okay? All right, what about I? So close, Lucas. Not 2. 8. Why is it 8? This becomes an exponent, which means it's 2 to the 3rd power, not 2 times 3, remember? You got the 12th part right, that's good, but you got to remember what to do with the whole numbers, okay? What about J? Isn't it just 7? Not even log? Because log base 5 of 5 is what? 1. And where has this gone? It's a multiplier. Okay. What about log base 6 of 6? What about log of 10 to the negative 4? Oh, why is it just negative 4 though? What's this base? 10. It's not going to be written if it's the common log. Remember, that's called the common log? Okay. What about M? 1? How does 1 even make any sense? 3 plus 4 is 7. Oh, it's times, isn't it? So it's really log base 12 of 12, which is 1. Absolutely. Okay? So this is when we're simplifying logs. What if we're asked to expand the logs? What if I have to expand this logarithm? What does it want me to do? It wants me to say log base 2 of 7 minus log base 2 of 3. And then it actually gave me some values up here. Okay, we can actually substitute those values in. I'm not so worried about this right now because this is really calculator stuff. We could do that with our, just by hand or whatever. I'm more worried about the expansion process right here. So this is as far as we're going to go today. I promise I'll make it clear what I want when it's time. But for today, I'm worried, can you expand it? What about 2? So you want to say log base 2 of 9 plus log base 2 of 2? My first question to you is, why did you choose 9 and 2? Why didn't you choose like 6 and 3? You just picked what popped into your mind, and what popped into your mind was the best choice. Why was it the best choice? It is factors of 18, but what's important about these two factors of 18? Really not both of them, just one. It's the 2. It's the base. Okay? It has something to do with the base. We chose 9 and 2 because it has a base of 2. What is log base 2 of 2? So this is really log base 2 of 9, like that, and then plus 1, isn't it? Okay? It's just recognizing what those values are. So what about number 3? Log base 2 of 3 minus log base 2 of 4. Done. So what about 4? Log base 4 of 3? Is that what you said? Oh, 4 cubed like this? Do we know 4 cubed? Try one more time. Oh, yeah, no, I'm sorry. That was right. That was right. 64. I was thinking 3 to the 4th. That was my fault. What about 5? Log base 2 of 8x. And why'd you do that? When we're adding our logarithms, we're multiplying the arguments. Okay? Think about how we said it with exponents. When we're multiplying like bases, we're adding the exponents. When we're talking about logarithms, when we're adding like logarithms, we're multiplying the arguments. Very similar, right? Okay? What about 6? X squared minus 9. Excellent. Again, multiplying the arguments because we're adding the logarithms. And what about 7? Log base 6 of, so we could say 8x plus 6 over 2, or log base 6 of 4x plus 3. Excellent. Okay? All right, so this is what we're going to do. Would you make sure everybody gets one of those, please? And then let me have the extras. When you get your paper, I want you to turn it over so you cannot see it. Turn it over so you cannot see it. And I would like to use the properties that we just figured out, that we learned about last night on the flip video, and that we've been practicing now to do these 6 problems. We're going to apply in class, not at home by yourself, in class what we learned on the video. Okay? So everybody look at number 1. Go ahead, go ahead. Nope, not yet. We're just looking at the board right now. You're just looking at the board. Log base 3 of 9 plus log base 3 of x plus 2 equals 4. What do you think we're going to do? We need to solve for x, right? Okay? We need to solve for x. So what we have is log base 3 of, I heard somebody say it already, 9 times x plus 2. Thank you. That's fine. Should we multiply it out? What do you think? Yes. Okay. Whoa. So we have log base 3 of 9x plus 18 equals 4. You remember how when Austin was doing a problem on the board earlier, and he got to a point where he couldn't do anything because of where the variable was? What did he do? He went to exponential form. Let's try that. Because if we go to exponential form, doesn't that get rid of the word log? Okay, so rewrite this for me in exponential form. 3 to the 4th equals, oh my gosh, can I solve that? Yeah, what's 3 to the 4th? 81 equals 9x plus 18. Subtract 18 from both sides. 63 equals 9x. X equals 7. Is it right? Log base 3 of 9 plus log base 3 of 9 equals 4. You're not getting your calculators out, are you? Because look, log base 3 of 3 squared, isn't that 9? What does that equal? 2 plus log base 3 of 9. 2 plus 2 equals 4. Oh my gosh. Turn your paper over, please, and copy it down. except for Lucas. Lucas, head to the board and start number 2. So let's see, Lucas has log base 5 of x over 2 equals 3. And then he rewrote that in exponential form as x to the third equals x over 2. Guys, if I don't rewrite it, they can't see it on the video. I'm trying to write it right where he's writing. So then he has, what does that say? Oh, 125 equals x over 2. And then you multiply both sides by 2 to get rid of this one. So 250 equals x. Is that right? Log base 5 of 250 minus log base 5 of 2 equals 3. Now, can we check this one the same way we checked that one? No, we can't, right? We've got to use a calculator to check this one. Do it real quick for me, please. Log base 5 of 250. Sorry. Log base 5 of 250 minus log base 5 of 2. Uh-oh. I forgot to use my arrow, sorry. Log base 5 of 250, there, minus log base 5 of 2. Yes! Good, Lucas. Excellent. Now Peyton's going to come back here and do number 3. Because then I don't have to try to write under where Lucas was writing. You got this. So what are you going to do first? Yes. She's going to move the 4 first. She's going to move it back to be what? An exponent, right? Okay. So she's going to write log base 9 of 3 to the 4th equals x. Just like she has, right? Now what are you going to do? Don't worry about that right now. You can do it like on the next step. Probably what you might want to do is write it in exponential form. When you get to where you can't do anything else with the log, try exponential form. So you can write 9 to the x power equals 81. You can go ahead and write 81 right there. Or the next step is fine too. 9 to what power equals 81? Perfect. Uh-huh. Is it right? Let's see. 4 log base 9 of 3 equals 2. Perfect. Who's next? Jake, I'm so proud of you for volunteering. So what are you going to do first? It is addition of logs, so how do you want to rewrite that? Do you have a pen? Okay, good. I understand. That's okay.
Log
216. Thank you very much. Thank you. Very good. Write it in exponential form. X to the third, x cubed. Okay. Do you know what what number cubed off the top of your head equals 216? Then you could refine the cube root in the calculator. Absolutely. Okay, that's a good question. Can I show you something real fast? Look at the little caret button right here. Look at the blue writing right above that. See how it says N and then X? So if you do, let's see, you have to do Control and then that button, and then you can put the cube root of 216, just like that. Okay? Is it correct? Log base 6 of 12 plus log base 6 of 18? It is, isn't it? Who checked it? Good, thank you. Okay. Who's got 5? Back here. Sure, that'd be great. You have a pen? You need my pen? Use my pen, please. So what are you going to do first? Move the 6. It becomes what? To the 6, right? It's an exponent. Okay? Okay? So now what are you going to do? Exponential form. Very good. Excellent. Thank you very much. Is it right? It sure is, isn't it? Okay. Who's got 6? Get back here. Whoever's doing it. Can I stop you for just a second? When we solve square root functions, how many answers are we supposed to get? Excuse me, squared functions? We're supposed to get 2, right? What are the answers that we could get? Plus or minus 8, right? Somebody asked me a question yesterday about can we have like negative bases. That was you, Lucas, wasn't it? Okay. Watch what happens. Oh, don't look yet. When you graph it, it says error?
Yeah, below.
Watch what happens when I check it that way. When I say 6 log of negative x of 2. Ah! Non-real calculation. So can you do it? Yes. Is it a real number answer? No. Okay? And so at this point in our Algebra 2 lessons, we're not going there. Okay? Good. Yes, absolutely. You can go through it now. It'd be fine. So tell me what you did real quick. It was subtracting to divided, and what did you do with that x right there? You simplified it, right? Perfect. You factored an x out of each term. Excellent. Okay, so keep going. Is it right? Yeah, get rid of that.
Keeping.
Yeah, go ahead and finish it so we can put it on the screen. Scoot it down just a little bit. No, it's fine. You just have to scoot it down a little bit so it's not glaring. Uh-oh, what happened? Hey, Lucas, let me see your calculator real quick, please. Oh, it's fine. We're good, though, right? Okay. Did you put an X in there on accident instead of a 16? Okay, that's probably what happened. It's okay. Thank you very much. All right, any questions about this?